So today we have a fun easy geometrical problem. The given data is that we have an equilateral triangle ABC. Now we fold this equilateral triangle from the top point along this dotted line DE such that the point A gets folded as and come point A dash over here. Now as this triangle is folded, this much length is going to be equals to this much length and this length is going to be this much length. You have to just close your eyes and visualize how this triangle has been folded along this length DE. And there are some given data, so you can just have a note over there that BA dash is having a length 2, CA dash is having a length 1, and in this particular triangle the length of DB is equals to length of DA dash. Now all these things are clear. Now what we have to find is the angle BA dash C that is present as variable x over there. So let us see the solution. So first of all, it was given that this triangle is folded, so let us utilize that. So as I told you, from the folded triangle we can have that this length is going to be equals to that length. So if I consider this length as a variable equals to A, so this much length is also going to be equals to A, and it has been given that this length is equals to that length. So this is also equals to A, so this complete length, that is BA, is equals to A plus A, that is equals to 2A. Okay. Now it has been given that this triangle ABC is an equilateral triangle. So if one of its side is equals to 2A, all this side is equals to 2 times A. That is not required, so I am not marking. Now the second thing we can utilize from an equilateral triangle is that all the three angles is equals to 60 degrees. So I am just assuming it over there. So let this angle be equals to alpha, let it be clear. Let this be equals to alpha, let this be equals to beta. And this complete angle is equals to 60 degree. Remember, because it's a corner of this equilateral triangle. Now what I will do is apply the cosine rule in this triangle and apply the cosine rule in this triangle, because in these two triangles the only variable present according to the side, because cosine rule takes the side, is A. So we can solve for the value of A. So in this particular triangle we have 2, we have 1, and if we get A we can get this third side. So if we triangle all these three sides we have, so we can just, according to again the cosine rule, we can get the value of x. So applying the cosine rule in this triangle, so I'm writing the triangle over there. So triangle is BA dash D. So in this triangle the value of cos of alpha, that is its middle angle. First of all, what is the cosine rule? If there is a triangle, this angle is equals to theta, the sides are x, y and z, then the value of cos of theta is equals to squares of the adjacent added together. So adjacent to theta is x and y, so x square plus y square minus the square of opposite to angle theta is z, so minus z square upon 2 times the product of adjacents, that is 2 times x times y. This is the value of cos of theta according to the cosine rule. So applying the same cosine rule in this particular triangle, that is triangle BA dash T. So the value of cos of alpha that is present over here, squares of the adjacents added together, so a square plus 2 square, that is a square plus 2 square 4, minus the opposite square, so opposite is again a, so minus a square upon 2 times the product of adjacents, that is 2 times a times 2, so 2 into 2, 4 times a, so a square and a square got cancelled out, 4 upon 4 times a becomes 1 times a, and that is the value of cos of alpha. Okay. Now we will calculate the value of cos of beta according to this triangle. So the other triangle is triangle BA dash C. So in this triangle the value of cos of beta is going to be 2 square 4 plus adjacent sides are 2 and 2 times a, so 4 plus, so other side is 2 times a, so its square becomes 4 times a square minus the square of opposite, that is minus 1 upon 2 times 2 times 2 times a. So here we have 4a square plus 3 and upon 2 into 2 into 2, that is 8 times a. This is the value of cos of beta. Now in this we can clearly have an idea that cos alpha is looking simpler, and why I am telling is that because alpha plus beta is equals to 90 degree, not 90, 60 degree according to this diagram, because it is the corner of this equilateral triangle. So alpha plus beta equals to 60 degree. So here I can keep beta on the LHS and shift alpha on the RHS side, so it becomes 60 minus alpha. Now taking cos on both the sides, so cos of beta becomes cos of 60 minus alpha, so cos of 60 minus alpha. Now according to the trigonometric identity, we can open cos of 60 minus alpha, so it becomes cos of 60 cos of alpha minus, as it is minus it becomes plus, sine of 60 sine of alpha, and that is equals to cos of beta. Now we have the value of cos of beta, that is equals to 4a square, so 4a square plus 3 upon 8 times a. The value of cos of 60 is 1 by 2. The value of cos of alpha is 1 upon a, so I am writing it over there, so 1 upon a, yes, plus the value of sine of 60 is root 3 upon 2, and the value of sine of alpha, as cos of alpha is having a value of 1 upon a, we can have that value of sine of alpha is going to be square root of, it's going to be square root of a square minus 1 upon a. It's very simple. So the value of sine of alpha is going to be square root of a square minus 1 upon a. Now we can see that from both the sides a and a got cancelled out from the table of 2, this 2 and this becomes 4. Now the cross multiplications from here, so 4a square plus 3 is equals to 4 plus 4 times the square root of 3 moves inside, so it becomes square root of 3a square minus 3. Now this 4's come over here and we can just square both the sides, so it becomes 16a to the power 4 plus 1 minus 8 times a square, and that is equals to 48 times a square minus 48. So minus 48. I can shift this both things over here, so I get that 16 times a4 minus 56 times a square minus not minus plus 49 is equals to 0. And this thing is very nice and clear. It becomes 4 times a square the whole square minus 2 times 4 times 8 times 7 plus 7 the whole square, and that is equals to 0. We can clearly have an idea, a square minus 2ab plus b square, so it becomes 4a square minus 7 the whole square, and that is equals to 0. So from here we get the value of a as square root of 7 upon 2. So this is the value of a, that is square root of 7 upon 2. So as I told you, if we get the value of a, we can just apply the cosine rule again in this particular triangle. So now we have a triangle like this way. This side is equals to 2, this side is equals to 1, this side is equals to 2 times a, and here's the angle x. So applying the cosine rule according to this angle x, so we have that cos of x, squares of the adjacent side together, so 2 square 4 plus 1, that is equals to 5 minus 2 times a the whole square, that becomes 4 times a square upon 2 times 1, so 2 times 1 becomes 4. Now we have the value of a, that is equals to square root of 7 upon 2. So from here we get the value of a square as 7 upon 4. So this is the value of a square, and I am going to replace the a square present over here with that a square. So replacing this a square with that, so we get that 5 minus 4 times 7 upon 4. So 4 into 7 upon 4 gives me 7. So 5 minus 4 is negative 2. And in the denominator we already have 4. So negative 2 upon 4 becomes negative 1 by 2. And that is the value of cos of x. So if cos of x is equals to negative 2, so what we can get is that the value of cos is getting negative. So now we can say the value of cos of x is negative 1 by 2, and we know that the value of cos is negative only in this third quadrant and fourth quadrant. To get in the third quadrant we do 180 minus theta, and for the 4 we do 180 plus theta. And according to this diagram, the value of x is going to be less than 180 because it's looking like it's less than 180. It cannot be greater than 180. So we have to just think of this quadrant. So what we have to do is just write this particular equation as cos of 180 minus x, and that becomes positive 1 by 2, and that is equals to cos of 60 degree. Because 1 by 2 is having a value that is cos of 60 degree. Now we can compare this and this. So we get that 180 minus x is equals to 60 degree. So from here we have that x is equals to 180 minus 60, that is equals to 120 degree. And x is equals to 120 degree is the answer that we are trying to find, that the value of this particular angle is equals to 120 degree. What we did is apply the cosine rule in this triangle to get the value of a. As we got the value of a, we again applied the cosine rule in that same triangle, that is the other one, to get the value of x. And at last we got that negative 1 by 2, so it's a kind of simple trigonometric thing to be solved, and we get that x is equals to 120 degree, and that's the answer. If you have any other method other than this, you can do comment below, or else you can DM me on my Instagram, link is in the description. And someone gives a better solution to the same question and we can show it to our viewers. It's best knowledge.